Okay. All right. Any doubts on trigonometry, whatever basic stuff we did yesterday? Mostly okay. Okay. All right. So we'll start with basic sine rule. So if I have any triangle like this, so let's just A, B, and C. And so the labeling of the sides I've told you in the past, it's the smaller letter of the corresponding vertex, right? So it's small a, small b, and small c. Now, if I drop a perpendicular from here to here, let's call that fine. Let's call that h. It's fine. Okay. Now, area of this triangle, area is generally denoted with delta, right? Delta stands for area. Is half base into height. So it's half into a into h. But h can be represented as, for example, let's say this is angle B, right? This is angle B. So h by c is sine B. So h is c times sine B. So I can replace that here. So it becomes half a c sine B. Okay. So the pattern is any two sides, and the included angle between them will be the other capital letter. So between small a and small c, you'll have capital B. So by symmetry, we can also express as half BC into sine A, and similarly half AB into sine C. So all of them will give the area, right? And in particular, if I have a right angle triangle, let's say this is C. Okay, let's say we are looking at this. So this is small c, and this is A, B, C, let's say, right? So this is small a, this is small b. So it becomes half into A into B into sine 90, which is why you see half A into B, right? For a right angle triangle, because sine 90 is 1. Okay, now this is the common area. Now I can divide throughout. By A, B, C, say, right? I can divide all the three equations by A, B, C. Let's say what happens because of that. So it becomes sine B by A and C get cancelled, B. In fact, I'll divide throughout by ABC, I'll divide throughout by half ABC, let's say. So the half gets cancelled and two of the sides get cancelled. So leaving only the third side. So sine B by B remains, sine A by A remains, sine C by C remains. I'll write it symmetrically here. Sine C by C remains. So this is the sine rule essentially. Right? To solve a triangle, you need three independent data. So when you say solving a triangle, the meaning to be able to uniquely draw a triangle, you need three independent information. The three independent information can be a side, side, and side. Okay, which is why these are the properties that you would see in congruence of triangles. When you try to prove two triangles are congruent, right? You use the SSS property because SSS is unique to identify a triangle. So if SSS match between two triangles, then the two triangles must be congruent. Okay, the other one is SAS. So this sine rule is somewhat related to SAS. The area of the triangle is half AC sine B, right? So given two sides and an included angle, the triangle gets determined, right? And then you have AAS or ASA. So this is equivalent to ASA, right? Because once you have two angles, the third angle is anyway determined. So I don't have to say another A, right? So when I have two angles, automatically the third angle is determined. All I need is one side alone, and that uniquely determines the triangle. What is not allowed is the donkey as, right? So as is not used for congruence, cannot be used for congruence. Cannot be used for congruence. Okay, so why is that? If I have two sides and a non-included angle, I cannot uniquely determine the triangle. So why is that? So let's take an example. So for example, let's say a side length. I'm giving you the specification. AB is in triangle ABC. I'm saying AB is, I don't know, maybe 12 centimeters. Okay. And angle A, which is not the included angle, right? So AB is small c essentially. So small c, which is AB, right? Angle A is given to be 30 degrees. Okay. And then the side A is given to be, let's say 8 centimeters. Okay. Now let's try to construct this triangle. Let's try to construct this triangle. So what will happen? So first thing, I'll construct a line, okay, to determine AB. So let's say this is my AB, right? I'll draw my AB, and then I'll draw a 30-degree line at A. Say this is 30-degree line. Okay. So I have to label, right? This is A, this is B, and this is 30 degrees. So I've done this part. This is 12 centimeters. Okay, I've marked off this 30 degrees I've drawn. Now, small a is nothing but BC, right? That's 8 centimeters. Now, I would want to cut an arc of 8 centimeters length with B as the center. I'll try to cut an arc. So if I cut an arc, you can imagine that goes like this, right? So it cuts at 2 different points, right? Here as well as here. So one, Sumer might mark the triangle like this. Keshav might mark the triangle like this. Both are right, right? Both are right. So you might mark the triangle like this. Okay. And another guy might mark the triangle like this. So because there are 2 answers, ASS is not a valid property. Note that this is also 8 centimeters. This is 8 centimeters. And so is this. Right? So I don't have a unique answer. So all of the 3 are satisfied in both the triangles. But the 2 triangles are not congruent, which is why you cannot use ASS to determine congruency. Now, it can be used for congruency under some special circumstance. Yes, Thais, go ahead.
Sorry, what does S and A stands for?
Oh, this is for the congruence of a triangle. S stands for side, A stands for angle. Okay, so congruency of triangles you would have done, right? SSS property, SAS property, that's what I'm doing. Sorry, I just thought it was obvious and didn't mention. Yeah, side, angle, side. When I say side, angle, side, it means the angle is included between the 2 sides. Yeah, so that's a valid way of congruency. What's not valid is if the angle is not included between the 2 sides, which is what I'm trying to illustrate here in this example. Okay, right. Now this is 8 and this is 8. Now, what is the critical point where it just graces through this side? So for example, I'm able to join a perpendicular from here to here, let's say. So if I'm drawing a perpendicular from here to here, okay, then that triangle will be unique. So such a triangle where it, right, where it just graces through will be unique. And we can find the length of this, because if it just graces through, that means it's perpendicular, right? And I can use, let's say this is, I'll call this H, right? So if I look at the triangle, let's call this C3, okay? So ABC3, for that triangle, sine 30 degrees would be opposite upon hypotenuse. H is the opposite side, 12 is the hypotenuse, and therefore we can infer that H is 12 times sine 30, which is 12 times half, which is 6 centimeters. So if it happens to be, the side happens to be 6 centimeters, then there is a unique solution. But if the side happens to be anything more than 6, there is 2 solutions, right? In fact, we can have a range of different values of the third side. So the third side, which is the small a, right? The small a. In fact, let's call this small a itself, small a, right? So if small a is, okay, so if small a is less than 6, right? And where am I getting this 6 from? It's 12 times sine 30. Then this implies there is no triangle at all, no solution at all. Right? Just imagine if I'm given a problem where small a is given to be not 8, but 4 centimeters or 5 centimeters. Then I cannot draw a triangle at all, because the triangle, when I draw an arc from B, it won't even cut the line, the 30-degree line anywhere. So I cannot draw the triangle. I can just about draw it when it's 6 centimeters. So when A is 6 centimeters, which is 12 sine 30, right? Okay, that's exactly one solution. Okay, and if A is greater than 6 centimeters, then you have two solutions. Almost. When I say almost, you keep increasing A, keep increasing A. Like with 9 it works, with 10 it works, with 11 it works. If it goes to 12, it comes like this, right? Which means there's back to only one solution. I cannot have C collide with A, right? In that case, there is no triangle at all. In that case, there's a unique solution, right? Let's say this is my C2 in such a case. C1 in such a case will not exist. We cannot, because I cannot have a triangle where C and A collide. So as long as it's greater than 6, but less than, let's write it in the reverse way. Let's write it 6 less than A. As long as 6 is less than A, less than 12, right? That means exactly two solutions. But if A is greater than or equal to 12, that means it's back to one solution again. For example, if small a is given to be 13 centimeters, come like this. So the only solution I take is the top one here, right? There's no chance of it cutting here, right? So what is the summary of this? There are cases where the solution will be unique, namely in this case or in this case, but not always you are guaranteed uniqueness, right? Which is why people don't suggest using ASS for congruency. All clear so far? Sumeri, you with me completely? Okay. Now, these two triangles, so back to the original picture where you have the C1 and C2, right? So let me erase all this extra clutter here. Sorry, I didn't to erase the whole thing. Okay, so if I take the original C1 and C2, the original C1 and C2, right? So these two triangles that are formed are such that this angle will be equal to this angle, right? So if this is theta, this will be theta as well. And therefore, this will be 180 minus theta. Okay, so technically, you don't see a violation of your sine rule. Why? Because in both the triangles, you still have the property that, okay, all right. So if I'm looking at the sine rule, 12 upon sine theta, if I'm looking at a triangle ABC3, ABC2, sorry, this is C2, and this is C1. Ignore this. Okay, if I'm looking at ABC2, then if I'm applying the sine rule, 12 upon sine theta is 8 upon sine 30. Okay, if I'm looking at the triangle ABC1, 12 upon sine 180 minus theta is 8 upon sine 30. Then is there a violation? 8 upon sine 30 is always 8 upon sine 30. Then I have sine theta here and sine 180 minus theta here. It so works out that sine theta will be same as sine 180 minus theta, right? So sine of 20 degrees is same as sine 160 degrees, right? So sine theta is same as sine 180 minus theta. So that leads us to looking at angles above 90. How do you determine sine, cos, and tan for angles above 90? So which we'll do that shortly. But I just want to illustrate that there is no violation. Here it's sine theta, and here it's sine 180 minus theta. How can both be true? Because the right-hand side is common for both. And it's true because sine theta is same as sine 180 minus theta. Okay, all right. So let's look at cos rule. So sine rule was this. So the cos rule is, if I have triangle here, Okay, so let's say this is A, this is B, this is C. Okay, now suppose I want to relate, can I solve the triangle using the three sides? So sine rule was given two sides and an included angle, I could solve for a triangle. So essentially, if small a and small c and capital B are given, then that's enough to solve the triangle, right? Sorry, I was just saying something. A, C, and B. Okay. Sorry, ignore what I said for a second. Ignore what I said for a second, right? Now, cos rule, right? So cos rule is, how do I relate? So let's say this is small c, this is small b, and this is small a, right? Now, is there a way to relate angle A with the sides A, B, and C? If the three sides are given, how do I determine capital A? Or if A, C, and capital B are given, can I infer small b with small a, small c, and capital B? Can I do both? Yes, you can do both of them, right? Given three sides, I can find any particular angle. Given two sides and an included angle, I can find the opposite side. Okay, so for both of these, the cos rule helps. How does the cos rule help? So let's draw perpendicular from here to here, right? Let's draw a perpendicular from here to here. Let's call this H. Okay, now let's split this base into two parts. Let's call this X portion, and let's call this is the remaining B minus X. Okay, now by Pythagoras theorem, we have C square equal to H square plus X square. Now in the right triangle, in the right hand side triangle, in this triangle, we have A square equal to H square plus B minus X whole square, right? B minus X whole square, right? And I can try and eliminate. So this is A square equal to H square plus B square minus 2BX plus X square. Okay. Now let's focus on this and the first one. Okay. So suppose I subtract, this is equation 3 and this is equation 1. So suppose I do 3 minus 1. If I do that, then I get left hand side is A square minus C square. On the right hand side, H square gets cancelled, X square also gets cancelled, leaving just B square minus 2BX. Okay, so I'll move C square to the other side. So it's B square plus C square minus 2BX. But what is X itself? If I want to relate X with C, X upon C is cos of angle A. In this left triangle, X upon C is adjacent side upon hypotenuse. So X is nothing but C times cos A, right? So ultimately resulting in small a square equal to B square plus C square minus 2BC cos A, right? So this is the cos rule. You'd see two forms of the cos rule. So this is one form where knowing two sides B, C, and the included angle capital A, I can solve for A, right? The opposite side to the included angle. The other form is if I rewrite the same, if I bring, let's say, cos A on this side. So if I say cos A, then I can bring the small a square to this side, and then I can divide by 2BC, right? I've got the plus 2BC cos A to the left hand side, and then divided by 2BC. This is another way of writing the same cos formula. This is given the three sides. Can I find any particular angle? So can I find A as a function of small a, small b, and small c? So I can do that, right? So that's the sine rule and cos rule. Any questions? Everyone is there, right, today, or anyone is missing? Let's see. Okay, I know someone is missing. I forget who. Okay, all right. Any questions so far? Keshav, all good? Abhya, Moksh, Dev. Okay, cool. So that's sine rule and cos rule. Now, yesterday we did sine of a plus b, cos of a plus b, tan of a plus b, and all that, right? So I didn't derive, but it's fine. We don't need derivation for sine of a plus b and a minus b and all that. It's fine. We can just go with that. Okay. So let's go to the next topic, which is deriving sine, cos, and tan for angles which are more than 90 degrees. So less than 90 degree, we are all confident, right? 0, 30, 45, 60, and 90. I'll just mark sine alone because knowing sine, you know cos, and knowing cos, you know tan, right? So 0, 1, here it's half, here it's √3/2, and here it is 1/√2. Okay, so this you guys should know solidly, no doubt about it. Okay, so let's draw a circle. Okay, so if I draw a circle, and let's say this is the center, and this is the coordinate axis. Okay. Okay, so this divides the circle into 4 quadrants. Quadrant 1 is our most likable quadrant, right? All angles are positive here. Angles are always measured with respect to the positive x-axis. So angles are always measured from here, right? So this is 0 degree, this is 90 degree, 180, 270, and 0 is effectively same as 360, and so on. Okay, now we cannot construct a, suppose I want to look at sine of 150 degrees. Okay, now I cannot have a right angle triangle with an angle of 150 degrees to say opposite upon hypotenuse. So that's not even feasible, right? So how do I make sense of this sine 150, right? So let me just draw 150 first of all. 150, it looks something like this, right? In this direction somewhere, right? So this angle is 150. Okay, now I don't like to think of sine 150 as opposite upon hypotenuse anymore. Instead, I'll look at the y projection, right? What do I mean by y projection? Suppose I project this onto the y-axis. So this is I forgot to mention, this is a circle with radius of 1. Radius is 1. So you can just imagine a rod is there and it's free to rotate anywhere on the circle. Right now we have rotated it 150 degrees from the positive x-axis. So right now it's sitting here, right? Now, I would like to think of sine 150 as the y projection. What do I mean by y projection? It's this height. That's the y projection. So sine 150 is this length. Let's say this is O. Let's say this is A. Right now we are B. Okay. So I'll just mark this as P, right? So OP is sine 150. I mean, assuming unit radius, assuming OB is 1, which I have marked, right? All the radius is throughout 1, right? OP is sine 150. But can I measure OP in a different way? Yes. If I can draw symmetrically a triangle in this direction here, right? So this length is also same, right? Now I know this angle by symmetry. If this is 150, this has to be 30, right? So that this balance is 30. So 150 is sort of equivalent to, I don't know how to write this, equivalent to 30 degrees, right? In terms of correspondence. So if I know sine 30, I know sine 150 directly. That's the idea. And in fact, that's exactly what it is. So sine 50 is sine 150 is sine 30, which we know is half. Right? Now I can do the same for cos. Suppose I need cos 150. Cos is the x projection. So cos theta is the x projection, x-axis projection. Sine theta is the y-axis projection. So sine theta is the y-axis projection. Okay, so what do I mean by the x-axis projection again? So if I want cos 150, I'll say this length OQ is my cos 150. Okay, can I find an equivalent one for one here on the first quadrant? Yes, I'll take the same 30 degrees. I'll say this measurement is exactly what I need, right? And this I know is cos 30. So cos 30 is root 3 by 2. So cos 150 is also root 3 by 2 in magnitude. That's the only difference. In signage, you have to let the diagram speak for itself. Is it on the negative x-axis or positive x-axis? It's on the negative x-axis. Therefore, you put a negative sign. So cos 150 is minus root 3 by 2. Right. And once I know cos 150 and sin 150, tan 150 is the ratio, which will be effectively same as tan 30. The only thing is it a plus or a minus? That extra thing we can figure out, right? So sin was positive, cos was negative. Therefore, effectively, tan will be negative as well. So tan 150 is negative of tan 30, which we know is 1 by root 3. So tan 150 is negative 1 by root 3. Okay, all clear so far?
So can you explain how you did cos 150 using x-axis projection?
Correct.
So that's
so
say
if
OQ.
OQ, exactly,
Right,
OQ.
okay.
So just imagine there's light falling all over from up and side everywhere, right? Where will the shadow of the point be fall on the x-axis? It will fall at Q. Correct?
Yeah.
Similarly, where will it fall on the y-axis? It will fall on P.
P. Yeah.
OP was already in the positive y-axis. Therefore, it was same as positive half, same as sin 30. Whereas OQ, lengthwise, it's same as sin cos 30. So let's say this is R, right? OQ in length, it's same as OR, but in signage, it's the opposite, negative, because it's on the negative x-axis. Clear, Dev?
Okay.
Guys, you're okay on this completely? Okay. All right.
Yes.
So same approach we'll take for the third quadrant. So let's try to figure out an angle in the third quadrant. So this is the first quadrant. So this is quadrant 1, right? Q1, Q2, Q3, and Q4. Okay. Now, before even we go to each quadrant, we can clearly say that sine will be positive here, because for any angle in the first quadrant, everything will be positive here, because for any angle in the first quadrant, the projection is going to fall on the positive x-axis and the positive y-axis. So all the quantities will be positive here. So I'll mark that as A, right? A, standing for all. In the second quadrant, the projection on the y-axis will be positive, but the projection on the x-axis will be negative. So I'll mark that as yes, meaning sine is positive, but cos will be negative, and therefore tan will also be negative. In the fourth quadrant, the x-axis projection will be positive, right? For example, if I have an angle here like this, something, right? The shadow will fall somewhere here. So the x projection will be positive, but the y projection will be negative, meaning cos will be positive, but sine will be negative, therefore making tan negative as well. In the third quadrant, both sine and cos will be negative, because for an angle like this, right? Both sine and cos will be negative. The projection falls on the negative x-axis and negative y-axis, and therefore the ratio will be positive. So tan will be positive. So this is the standard ASTC that you have studied, right? And people have different mnemonics to remember this ASTC. All students take calculus, all silver teacups, something. Like people over the years have made up their own mnemonics for it, whatever way you want to remember. Are we all good? You know this ASTC, right? Okay, cool. So let's try to take an angle in the third quadrant, the one that we have drawn. Let's say this is 240 degrees. It looks like 180 degrees plus a further 60, right? So 240 degrees. I'll draw another picture so that it's clearer. Okay. I'll draw the x and y axis.
So what if
Yes.
we give something like cos 125? And then you
all you know is it's same as cos of 55 with a negative sign, but numerically you don't know. You need a calculator or something to figure it out.
Oh.
Yeah. So same for even first quadrant. Why even go to second quadrant? Even cos 55 you won't know, right? Or cos 42 you don't know, right? Okay. So where were we? Okay. So let's say I'm drawing an angle at 240 degrees. 240 degrees is 180 plus 60. So something like this, right? So this is 240 counted from the positive x-axis. So this is 180 plus another 60, which is 240. Now, the obvious equivalent angle in the first quadrant would be 60 degrees to compare, right? That's called the principal angle. So the principal angle for 150 degree was 30 degrees. The principal angle for 240 degrees is 60 degrees. So if I draw 60 degrees here, this is 60. Okay, this is right. So this point, let's call this, I don't know, P, and this is Q. Okay, so the projection of this falls here R, the projection of this falls here, let's say S, and let's say this is T, and this is U, right? So now we know that the Y projection is OR, which is same as OU in magnitude, but negative, right? And similarly, the X projection is OS, which is same as OT in magnitude, but negative. So negative OT and negative OT. Okay, so which means, so this is, which one did I write first? I wrote the, okay, all right. So this is the X projection, right? This is the X projection, right? So cos 150, not 150, 240. So cos 240, so this is 240 degrees. So cos 240 is same as minus cos 60. And therefore it is minus 1/2. Cos 60 is half, it's 1/2. Okay, so in a triangle like this, so this is 1, this is 1. So this is 1/2, and therefore this is 1/2 in magnitude, but negative signage. Similarly, sine 240 is negative of sine 60. Right? So this length is √3/2 from here to here. Right? So, and therefore this length is also √3/2, the negative signage. Okay, so sine 240 is right. So again, you don't have to remember, but right now we have formed some pattern. So what do we know so far? So sine 180 minus theta is same as sine theta, whereas cos of 180 minus theta is cos theta. Sorry, minus cos theta. That's what we saw on the first page. Now we are looking at sine and cos of 180 plus theta. So sine 180 plus theta was negative sine theta, as we just saw. Sine 240 was negative of sine 60, and cos of 180 plus theta was negative cos theta. Okay, and tan, of course, is the ratio of the two. So okay, fine, I'll write tan 180 minus theta, therefore is minus tan theta. And here, right, it is tan 180 plus theta is same as tan theta, because the minus and minus get cancelled. And sure enough, I expect tan to be positive here, right? So tan is positive here. Everything is positive in the first quadrant. Sine is positive here. Cos is positive here, ASTC. Okay, so similarly, one example in the fourth quadrant, let's say, right? So let's say I have, fine, what should I take? I'll just take 330 degrees, let's say. Or let's say 345 degrees. Sorry, 315 degrees, I'm sorry. So this is 315 degrees, which is halfway between 270 degrees and 360 degrees. So the equivalent angle in the first quadrant would be the 45-degree line here. Right? The principal angle for that would be 45. So which means we know, how do I know? Just by reflection, right? So if this has to fall here, right? And the corresponding one that falls here is obviously the same angle here, right? So this is, if this is 45, negative 45, this has to be positive 45. I'm sorry, a lot of clutter here, but hope we can follow along the color, right? So can ignore the 60 and all right now. So the plus 45 and the minus 45. So the equivalent angle is 45 degrees, right? So which means I know cos of 315 will be same as cos of 45. Now, is it positive of cos 45 or negative of cos 45? It's positive, because the X projection is, yeah, exactly. X projection is on the positive X-axis, whereas sine would fall on the negative Y-axis, right? And therefore it is negative of sine 45. Okay, so if I extend this summary here, therefore I have cos of 360 minus theta is cos theta, right? Whereas sine of 360 minus theta is negative sine theta. Okay, so by the way, I can write it as 360 minus theta. I can ignore 360 completely, right? Anything with 360 I can completely ignore. So I can equivalently write cos of 360 minus theta as cos of negative theta. Similarly, I can write sine of 360 minus theta as sine of minus theta. So traveling 360 minus theta in the positive direction, as in the anti-clockwise direction, is the positive direction. So this is same as traveling negative 45 in the clockwise direction, right? Traveling 45 in the clockwise direction, which is negative, right? By convention, anti-clockwise is positive, therefore clockwise is negative. So minus 45 is same as plus 315. Okay, now in all of these cases, notice that I've talked about multiples of 180 plus minus, 180 plus theta, 180 minus theta, 360 minus theta. Of course, 360 plus theta will be back to the first quadrant. So no surprises there. So sine of 360 plus theta will be back to sine theta only, because everything is back to the first quadrant. So cos of 360 plus theta will also be cos theta, and similarly with tan, because everything is back to first quadrant. Okay, so as long as we are operating as 180 plus something or 180 minus something, sine will stay sine, cos will stay cos, right? And tan will stay tan. The only thing is you have to put a plus sign or a minus sign, that the figure will tell you, right? And right now you have to probably initially, when you're practicing, you have to draw the figure explicitly. After a few attempts, you'll see it for yourself. You don't even have to, you can just visualize and just write down the plus or minus very quickly, right? So okay, so that's offset from 180. Now, you also have to look at angles offset from 90. So what does sine of 90 minus theta mean? First of all, let's stick in the first quadrant itself. In the first quadrant itself, sine of 90 minus theta, right? That's cos theta, we all know it, but let's understand what that is, right? So if I'm viewing, let's say this is my theta, right? Okay, so let's say this is my theta, right? This is my 90 minus theta. Okay, so if I'm looking at sine of 90 minus theta in this triangle, in the top triangle, this becomes the opposite side, because as far as 90 minus theta is concerned, this is the opposite side. The hypotenuse is still same. Whereas if I'm looking at the adjacent, the lower triangle, as far as theta is concerned, this is the adjacent side. So sine 90 minus theta is this. Okay, I'll explicitly write A, B, C, D, right? So if I'm looking at sine 90 minus theta from the top triangle's perspective, it's BC upon the hypotenuse OC. Whereas if I'm looking at cos theta from the lower triangle's perspective, cos theta is adjacent upon hypotenuse, which is OA upon OC. But we know that BC and OA are the same length, right? It's just a rectangle after all. BC is same as OA, right? So which means sine 90 minus theta is same as cos theta. Okay, and same thing will happen if I go to the second quadrant, except that you just have to worry about the signage. That alone we have to worry. So I'll just illustrate it. So if I had the coordinate axis here, and let's say I draw, let's illustrate with a 120-degree angle itself. Okay, so let's say I draw 120 here. Let's say assume this is unit radius. Okay, so I'm looking now at 120 as sine of 90 plus 30. Instead of looking at it as 180 minus 60, I want to look at it as sine of 90 plus 30, right? And this is same as cos 30. Why is that? So this is 90 plus 30, which means the original 30 was sitting here, right? The original 30 was sitting here. Okay, the original 30 was sitting here. right? I took that, so this is 30. I took that and rotated it further by 90. So this is 90 to make sine of 90 plus 30. But lengthwise, if you see, right, what I'm seeking here is, right, this is my cos 30, right? And this is my sine of 120. Because sine 120 is the y projection. Y projection falls here. So which means sine of 90 plus theta is same as cos theta. Are you with me completely? Sumer, you're with me? There? Okay. Whereas with cos, magnitude wise will be the same, but signage will change. So cos of 90 plus 30, if I look, so cos of 90 plus 30 will be the x projection. So which means this is cos of 120. Okay. And what is sine 30 in length is same as this, right? You're able to visualize that it's the same rectangle. Everything has been just rotated by 90 degrees. So lengthwise, it's same as sine 30, but magnitude wise, it's negative because it's falling on the negative x-axis, right? Right. So how do I summarize? So if I have sine of 90 plus theta or sine of 90 minus theta, or if I have cos of 90 plus theta or cos of 90 minus theta, or if I have sine of 270 plus theta or sine of cos of 270 plus theta, and similarly with sine of 270 minus theta or sine of 270.
Question.
Just 1 second, I'll just write this out. Right, cos of 270 minus theta. So all of these will be the corresponding, and not corresponding, will be the opposite. Only thing is the plus or minus is questionable, which we'll fill right now. So this will be cos theta. This will be sine theta with the plus or minus, we'll figure out. This will be sine theta. So sine will change to cos, cos will change to sine. So I'll write this out and then I'll take your question. So this will be sine, this will be cos, right? And this will be sine. The only thing is we'll have to put a plus or minus ahead. Yeah, go ahead, please.
No, so this was my only doubt. So like, I think you can answer it.
Yeah, okay, good. So whenever I have an odd multiple of 90 plus or minus something, then sine becomes cos, cos becomes sine, as well as similarly tan becomes cot, right? Now, sine of, now how do we express the plus or minus? We just assume that theta is an acute angle. First of all of this is true, even if theta itself is obtuse or theta itself is reflex, doesn't matter. Theta itself can be a big angle, but just for understanding, just assume theta is between 0 to 90 and let the quadrant speak for yourself. If theta is an acute angle, 90 plus theta will fall in the second quadrant. In the second quadrant, we know that sine is positive because that we know, right? ASTC. ASTC we have already covered, right? In the second quadrant, we know sine is positive. Therefore, it will be just plus cos theta. Note that all of these are positive, right? Whatever I've listed down here before the signage, I'm assuming theta is anyway acute, right? So all of this is positive. So finally, do we have to put a plus or a minus on top of that? Sine of 90 minus theta, we already said, right? It's in the first quadrant, therefore it's positive. Cos of 90 plus theta. The 90 plus theta angle will fall in the second quadrant. In the second quadrant, we know cos is negative, and therefore it's negative sine theta. That's it. You already know it's some version of sine theta. The only question you had is plus or minus, and that you have answered now. Cos of 90 minus theta, the 90 minus theta angle falls in the first quadrant, therefore it's positive. Cos is positive. Don't look at the signage of the right side column. Look at the signage of the left. Whatever you're trying to calculate, that is what you should look at the signage for, right? So sine of 270 plus theta, right? 270 plus theta falls in the fourth quadrant, right? This is 270. 270 plus theta falls in the fourth quadrant, where sine is negative. Therefore, it's minus cos theta. Cos of 270 plus theta, 270 plus theta falls in the fourth quadrant again, where cos is positive. Therefore, it's plus sine theta. 270 minus theta falls in the third quadrant, where both sine and cos are negative. Therefore, it's minus and minus. Does it make sense? Again, you don't have to remember anything. If you understand what's happening, you don't have to remember all of these. It's impossible to remember so many, right? You should understand what's happening. If you understand, then you don't have to remember. Okay, all good. Thais, you're with me completely? Oh, Sarah is missing today.
Yes,
Yeah,
sir.
no doubt. Yeah, Sarah is missing. Yeah, okay. Amit, why is your video off? I just observed. All okay, Amit? Amit, are you there?
Yeah, my internet's pretty bad at the moment.
Okay, let me know ahead, please, if that's the case. And ideally, I would want to hear from your mom that, not that I don't believe you, but I just want to make sure that the parents are also aware. Keshav, all good? All known stuff so far, right? Okay, cool. So we covered sine, cos, and tan for any angle. So just for practice, maybe, can we list out, I'll just give a bunch of these. Okay, so let's, cosec, by the way, is reciprocal of sine. All of you know this. Cosec of 300, can you start listing out values for all of them? Without calculator, of course, right? So sec of 135 degrees. Can all of you start working these?
The sec is cos, right? And cot is
Sec-
tan.
Correct. Sec is reciprocal of cos, cot is reciprocal of tan. Yes. Moksh, you had a doubt?
No, I got the answer.
Oh, okay, okay. I'm listing out a few. I'll give everyone a chance, so don't worry. Okay. I might not be going in order. How shall we do this? Okay, I'll give 2 minutes for all of you to work all of these out, and then we'll discuss.
So is it fine if we refer to the values that we already know, like as in like what sine 30 is?
Fine. Ideally, you should know, right? There's only 3 numbers, right? 30, 45, and 60, right? 0 and 90 anyway, pata hai, right? So try to internalize those 3 values, please. But yes, for now, yes.
So is that tan negative of 120?
Correct. Yes.
Okay.
Negative is going in the clockwise direction. So you can convert it into a positive problem.
Okay, so it would be 240.
Correct. You can keep adding 360s, as many as you want, right? For example, if tan of minus 1000, I'll add 360, not enough. 720, not enough. 1080, enough. So tan of minus 1000 is same as tan of 80 because I've added multiple 360s. Okay. How long more before we start discussing? They've almost done. Which one are you on?
And the last one.
Okay. Sumer, almost done as well.
Yes, I'm just confused on one.
Okay.
So can you just, sorry, confirm which one is the inverse of sine and which one of cos, like between sec and cosec?
Okay. Good that you use the correct wrong word, not inverse, but reciprocal. Right? We are soon going to be talking about inverse also. So that's a different story. Yes. Reciprocal of sine is cosec. Reciprocal of cos is sec.
Yes.
Okay, let's start. Avya, you want to take this one? Cosec of 300. Explain, and first you can call out what you got, and then you can explain.
I got 2 root 3 upon 3.
2 root 3 upon 3. Okay, all right, like this. Which is okay, fine. 2 upon root 3 or 2 root 3 upon 3. Fine, which is effectively same as this. Okay, explain.
I think it's negative, so I think
Negative. Okay, all right. Explain.
So cosec 300 is basically 1 upon sine 300.
Yeah.
So and sine 300 is minus root 3 by 2.
How do you know sine 300 is minus root 3 by 2?
So I did 360 minus 60.
Exactly. That's exactly what I wanted to know. 360 minus 60, and which is in the fourth quadrant,
Yes,
where
sir.
sine is negative.
Hmm.
Right? I wanted you to take us through all that. Okay, good. Yes. And therefore, it's 1 upon negative of root 3 by 2, which is exactly the answer that you have. Well done.
Yes.
Okay. All right. Thais, you want to try this? Sec 135.
Sir, I think I got it wrong.
Okay.
Because I didn't.
Okay.
Like, it didn't-
I'll pass it to someone else. Dave.
Yeah.
So I got minus 2 over root 2.
Minus 2 over root 2. Okay. Explain.
So
Why would you write it as
135.
minus 2 over root 2, by the way? Isn't it better write it as minus root 2 then? Ideally, you would want to have root in the numerator,
Yeah.
right? 2 over root 2 is not helping at all, right? At least 2 root 3 over 3 helps because he wants to have the root in the numerator. I would have
Yeah.
accepted 2 by root 3 anyway, but 2 by root 2, there's no point in writing 2 by root 2. It's root 2 effectively, right?
Mhm.
Okay, tell me why.
Yeah. So if you think about it, cos 135 is, or like you can also say is a cos of 45, and then so it'll be 1 upon cos 45, but because it's in the second quadrant, it'll be minus.
Yeah, so you're viewing it as cos of 180 minus 45, right? That way,
180 minus, yeah, 180 minus.
right? Which is 1 upon minus cos 45. Yeah. Okay, I can also view it as 1 upon sine of 90 plus 45. So sorry, not cos of 90 plus 45, but cos of 90 plus 45 will change to sine, and cos is negative in the second quadrant. Therefore, it's
Yeah.
same as 1 upon minus sine 45. Here you got 1 upon minus cos 45. Here you got 1 upon minus sine 45. What is wrong, or is it all same?
945 is root 2. I think it's the same.
Exactly. Sine 45 is same as cos 45. Therefore, there's no inconsistency. Either way you look at it, it's 1 over negative 1 over root 2, which is indeed negative root 2. Yeah, does it make sense? Two ways of looking at it.
Yes.
Okay, all right. Moksh, can you take, I'm not going in order. Can you take cos of minus 300?
Okay, cos of minus 300 is just the same as cos of 60.
Okay,
And-
so you're just adding 360. Okay, all right.
And we know cos of 60 is 1 upon 2.
1 upon 2. Yeah. Keshav, tan minus 120.
Got root 3.
Tell me why.
Tan of this is just basically tan of minus 60 below the 180, so 240.
Yeah, so just add 360. That way it's
Yeah.
very safe, right? So which
Yeah.
is same as tan 240. Okay. And
Yeah.
240 is 180 plus a further 60. Yes,
Yeah, so then from there you can just get root 3 because minus over minus.
correct. And tan is positive in the third quadrant. And tan 60 we know is root 3. Okay, very good. Sumer, cot 150.
Yeah, so it's, we know cot is 1 upon like the reciprocal of tan.
Correct.
So all I did was just found out, we know what tan 30 is. So I just took it as 180 minus 150.
And therefore, is it plus tan 30 or minus tan 30?
It's minus because tan is negative in this quadrant.
In this quadrant, meaning which quadrant is this?
The second one.
Correct. And therefore, it's 1 upon, what is this? Minus tan 30 is how much?
Square root 3 by 3, which is just minus in this case.
Yeah.
Which is just minus 3.
Louder, the last step, minus root 3, right?
Yeah.
Minus root 3, yeah. Okay. Who's left? 480. Thais, you're okay to take 480 or should I give it to someone else? Dave, did you answer one? You answered the second one, right?
Yeah, I
Okay.
answered the second.
Okay, Dave, sorry, Thais, you want to take sine 480?
Sorry, I was a bit confused with like.
I'll help you. Did you follow along all of these so far?
Yeah, yes.
Okay, so 480 is exceeded 360, right? So I can
Yes.
safely subtract or add as many 360s as I want, so that I can get
Okay.
my angle within 0 to 360, right? So I'll subtract 1 360. So effectively, I'll say this is same as sine of 120 degree. You're with me so far?
Yes.
Okay, and I can write this as sine of 180 minus 60,
Yes.
right? And we saw the very first thing was sine of 180 minus theta was same as sine theta.
Mhm.
Remember this?
Okay.
So sine of 60, which we know is root 3 by 2.
Okay.
Does it make sense how to go step by step, guys? Okay,
Yes,
please
sir.
practice and
Yes.
then you'll get it.
Okay.
Okay, cool. So we covered angles which are more than 90. And then the next thing I wanted to cover was, suppose I have something as 3 cos theta plus 4 sin theta. Okay, and suppose I want to write it as, so suppose I want to know what is the maximum and minimum value this will take, right? 3 cos theta plus 4 sin theta. Maximum and minimum value this will take, right? Obviously, we know cos theta takes maximum of 1 and minimum of -1. So this expression itself ranges from +3 to -3. Likewise, this itself ranges from +4 to -4. But the combination, if I look, I want to understand because sine and cos are going in opposite direction. When sine is increasing, cos is decreasing. So if you look at the combination, what is the maximum and minimum, right? The way we do this is, we can write this as r times cos of some theta plus alpha. Okay, so how can I write that? Or r of sine of theta plus alpha, either way, right? In fact, I'll write sine. Sine of theta plus alpha. We can do both. Both are similar, right? Suppose I want to write it as r sine theta plus alpha, or rather, if I'm able to write it like this, then I can say the maximum value it will take will be r, the minimum value it will take will be minus r, because it's just a magnitude r multiplying a sine. Correct? You're with me? Okay, now what is the right hand side? So right hand side is, if I expand sine of a plus b, is sine a cos b plus cos a sine b, right? So sine theta cos alpha plus cos theta sine alpha. Okay, so that's the right hand side. And the left hand side is 3 cos theta. I'll write the 3 cos theta here. I'll write it as 3 cos theta here and 4 sin theta here. So if these two should match, my cos thetas match, my sin thetas match, if I'm able to somehow get r cos alpha to match 4 and r sin alpha to match my 3, then I'm good. Are you guys with me? Okay, so which means if I let's say I divide sin the second one by the first one, then I get tan alpha is 3 by 4. So if I'm able, and then okay, so I have alpha, so I've solved for alpha. So alpha is such an angle whose tan is 6 by 4, and that's written using the inverse function, right? Just like all of these are functions. Sine is a function, cos is a function, tan is a function. Now I'm talking about inverse function, right? Not the reciprocal, but inverse. It's tan inverse of 3 by 4.
So question,
An angle alpha. Yes.
wouldn't tan inverse be a relation, not a function, because you can get multiple outputs for a specific input?
Yes, that depends on how you define tan inverse. We'll come to the domain and range of tan inverse. We can define such that it's a function.
Okay.
Yes, but on the cuff, it looks like a function. On the cuff, it looks like a relation, but you can define the domain and range such that it's a function. Good point. I'll come to that.
So
Okay.
can you explain this again? I didn't understand the whole R, like why is R cross alpha 4? I
Oh,
didn't get
okay.
it.
You understood how I expanded R sine theta plus alpha as this.
Yeah.
Okay. And then I try to match terms with the left hand side. Whatever is cos theta, the magnitude of cos theta was R sine alpha, and the
Okay.
magnitude of cos theta was 3. Therefore, I'm matching both. You with me?
Yeah.
Sure, right, Dev?
So you took sine, wait, you took cos theta as minus sine theta?
No. I didn't do any negative, nothing. I expanded R sine theta plus alpha. Should I repeat it once quickly? I'll just do it once more so that it's not very, maybe it was not very clear. Okay. So what is my goal? My goal is I want to find the maximum and minimum value of 3 sine theta plus 4 cos theta. Right now I cannot do it because cos is going up and down, and sine is going up and down in a different way, right? So if sine increases, cos will decrease. So optimally, when will both be at such a point, this is the sum is maximum. Suppose I want to find out what's the maximum and minimum value of this entire expression. Now, tackle this, I'm saying, if we are able to write it, and say if, but you'll see that we are able to write it. If we are able to write it as sine of R times sine of theta plus alpha, then R becomes the magnitude, right? Sine of theta plus alpha will go from +1 to -1. Therefore, the maximum value this will take will be plus R. The minimum value will be minus R. You're with me?
Yeah.
Okay. Now, what is R sine theta plus alpha? Sine of A plus B is sine A cos B plus cos A sine B. So this is R sine theta cos alpha plus R times cos A sine B, which is cos theta sine alpha. But this must match the expression on the left side. So if it must match, then the easiest way for me to match is if I'm able to match the 3 cos theta with R sine alpha into cos theta. If the 3 and this match, and similarly the 4 sine theta, if I'm able to match the 4 with whatever multiplies the sine theta, which is R cos alpha. Are you with me?
Yeah, I think I got it.
Right? So in other words, R cos alpha is 4, R sine alpha is 3. Let me try to solve for R and alpha. I don't know what R is. I don't know what alpha is. Theta is given to me, right? So theta is known because on the left-hand side, I have some theta, right? 3 cos theta plus 4 sine theta. In terms of theta, I have.
Yeah.
Okay. Okay. I should not say theta is known. So theta is already given in the problem, right? I can continue to have theta in my problem. Alpha is something I made up. R is something I made up. So I'll have to solve for R and alpha.
Yeah.
Right. So one way of solving for alpha is if I divide these two, I get tan alpha is 3/4. So alpha is such an angle whose tan is 3/4. And the way I write it is alpha is tan inverse of 3/4. Okay. Now, how do I solve for R? I can take the first expression and square it, and take the second expression and square it and add. When I do that, I get R square cos square alpha plus R square sine square alpha. This is just standard solving technique, right? Is 4 square plus 3 square. And we know that cos square alpha plus sine square alpha is 1. Okay. Therefore, this is 25. So which means R is generally a positive number. So R is, you could argue R could be plus or minus 5, but I'll take the positive root, right, of 25, which means I can write this expression, the left-hand side, I can replace this entire thing by R, which is 5 times sine of theta plus alpha. Alpha is nothing but an angle which is tan inverse of 3/4. Are you with me? All of you?
Yes.
Avya, you're with me? Therefore, the maximum value this will take will be plus 5, and the minimum value this will take will be minus 5. Okay. So this is a standard technique used to find maximum and minimum. Okay. Now maybe we should touch on inverse, right? Inverse trigonometric ratio. Okay, so now if I look at my sine itself, let's take sine inverse first. So this is the x-axis. This is the y-axis. Okay, so sine goes with a period, right? A period of 360 or 2 pi. Okay, I'll stick with, I'll keep going back and forth between radians and degrees so that you guys are aware. So this is my 180. So sine 180 is 0. You can just imagine, right? On the circle, on the unit circle, where is the y projection 0? When the angle is at 0 degrees, obviously the y projection is 0. When the angle is at 180 degree, also the shadow falls on the y-axis at origin itself, which means sine 180 is 0, sine 360 is 0, and so on. For sine 540 is 0, and so on. Now, the peak occurs at 90. So sine 90 is 1. And the trough occurs at 270. Sine 270 is -1. Again, you can imagine on the unit circle, when I am at 90, right? When the angle is at 90, the projection is right there on the y-axis, positive y-axis, which is of length 1. On the other hand, if I'm at 270, the projection is on the negative y-axis of length 1. So which is why sine 270 is -1. So this is -1, and this is +1. Okay. Now, if I'm looking at what is sine inverse of half, okay. So if I draw the line which is of height half here, right? I get infinite answers, right? So one guy is telling me that sine inverse of half, right? So, or rather, one guy is telling me when theta is 30 degrees, sine 30 is half. This guy is telling me at 150, sine theta is half. The next one is in the back after finishing the full circle. If you go to 390, right, it's half. And similarly, at 510, it's half. Right? So who do I believe? Or rather, can you give me one number for sine inverse of half? This is back to what Moksh was asking. If there are multiple answers to this question, we say 30 and 150 and 390 and so on, then it's no longer a function. It's a relation. So how do you make it a function? We make it a function by saying sine inverse of half is to be an angle between -90 and +90. Okay. Okay. And maybe I should draw some angles below this as well. Okay. So -90 and +90. So why did they pick -90 and +90? Because it's the interval where you can uniquely guarantee a value, but all the values from -1 covered. So if I'm covering this range from -1 to +1, and if I'm confining myself to this interval from -90 to +90, right? So the output of, or rather the output of sine inverse of x, right? Sine inverse of not an angle, sine inverse of a value will be an angle between -π/2 to π/2. Moksh, just 1 second. Okay, so I'm guaranteed to cover every value from -1 to 1, both included. Sorry, I should put less than or equal to. Right, both included. So in this region, I only have one answer, namely 30 degrees. Yeah, Moksh, your question. You had a
So
question,
can't you
Moksh.
just put the answer for sine inverse of half? If there's no given domain provided, can't you just say the answer for sine inverse of half is 30 plus 360n and 150 plus 360n, where n is an integer?
No, but if you do that, then you're getting multiple answers, right?
Yeah, that's a way to represent all of the answers.
Yeah, but you must have, when someone asks for sine inverse of half, suppose you want a unique answer. What will that unique answer be? Yes, everyone
Okay,
understands.
then
Yeah.
you'll have to give the domain, yes.
Yeah, you have to give the range.
No, like
Right?
you'll have to, like, the function will have to be, the sine inverse function will have to be defined like within a particular domain.
No,
That's how you can get only one unique value, right?
you're right, but defined with a given range. The input is for the input to the sine inverse is a value x, which is between -1 and +1. That's the domain. right? So we're talking about sine inverse now,
Oh, my bad. Okay, yeah, got
right?
it.
So no problem. So we are talking about sine inverse. This function is sine inverse.
So
So
if we have to limit the domain of the sine function and the range of the sine inverse function of sine inverse relation.
correct, exactly, right?
Got it.
If you're looking at sine inverse itself, then the input that comes here, it better be between -1 and 1, right? Because if you ask me, right, if you ask me what is sine inverse of 1.5, that's meaningless, right? No, not degrees, it's a sine of 1.5, sorry. Sine inverse of 1.5, I cannot do it. I cannot do sine inverse of -2 also. I can only do sine inverse of a quantity which is between -1 and 1. That's
Yeah.
the domain. So that's the domain. Now the range of sine inverse of x is an angle y, right? We are reversed, right, between the angle and the value, right? The output of the sine inverse function is an angle. So y is this angle here. And we are saying this angle will be restricted between -90 to +90. Or if you look at it in the radian, it's pi/2 to -pi/2. Does it make sense? Everyone with me completely? Keshav, you with me, right? Okay. Now, same thing for cos, and similar thing for cos, but how will the cos function look like? So how will the cos function look like? So this is my x-axis. I can draw a straight line better. Okay, this is my x-axis. This is my y-axis. Okay, so the cos function, cos 0 would be 1, right? Cos 90 would be 0. And then cos 180 will be, again, just imagine you're on the unit circle, right? Cos 90, when the pointer is at 90 degree, the x projection is 0 because literally the shadow is falling on the origin, right? On the other hand, if it's a 180 degree, it's on the negative x-axis, which means the x projection is maximum negative, right? So it's -1 at 180, and then back to 0 at 270, and then rises up to 1 back at 360. So this is one full cycle of cos. Okay, and then I can go further here. So cos is an even function, by the way, right? Now that we know what even function and odd functions are. So cos is an even function, which means cos of minus theta is same as cos of theta. And this is in conformity with in the fourth quadrant, cos is positive, right? Because this is equivalent to cos of 360 minus theta, right? So cos is positive in the fourth quadrant. My 360 minus theta is effectively same as minus theta. So cos 360 minus theta, which is same as cos minus theta, is equivalent to cos theta, which means cos is an even function, which means it's a pure reflection around the y-axis. So the cos will look like this, right? So for this function, suppose I have to restrict my range. Again, the same problem. Suppose I want to find what is cos inverse of half. So if I draw the half line here, right? So didn't come out parallel, sorry guys. Okay, so one guy will end up saying it's 60 degrees. One guy will say it's -60 degrees, right? And one guy will say it's the fourth quadrant, it's how much is this? 330 degree, I think, right? 330 degrees, yeah. 330 or, yeah, 330. 300, sorry, 300. 360 minus 30, right? So which one do we believe? So we want to restrict again so that there's only one unique answer. Plus, we must make sure that every input between -1 and 1, because cos also takes an input which is -1 and 1, right? So this cos function, cos inverse function, the input must be, x must be between -1 and 1, so that I can answer the question cos inverse of √3/2 or cos inverse of half. I cannot answer sine inverse of 1.5, sine inverse of -2. I can, however, answer sine inverse of -0.672, for example. I can answer this. I mean, I need a calculator, but I can still answer this. I can also answer sine inverse of 0.999. I can answer because it's less than 1. Okay, so similarly, cos inverse of half, the output should be unique. So if I choose the same -90 to 90, that's not going to help, because between -90 to 90, the cos function is only positive. It ranges only from 0 to 1. So I need to pick the range such that it's able to accommodate all inputs from -1 to 1. So a better range for cos would be if I pick from 0 to 180. So if I pick the output as 0 to 180, the angle is between 0 to 180 degrees, then, or in radians, it's 0 less than or equal to y less than or equal to pi. Then I cover all the way from +1 to -1. So if I'm given -1, I know the answer is 180. If I'm given plus 1, the output is 0. Cos inverse of 1 is 0. Cos inverse of -1 is 180 degrees. Cos inverse of 0 is 90 degrees. Cos inverse of half is 60 degrees. Like that, I can keep answering any cos inverse as long as that input is between -1 and 1. Okay, all of you good on this? Yeah, Sumeri, all good? Okay, cool. Now, same with tan, right? So how does the tan function look like? So sine and cos have a period of 360 degrees. They repeat after 360, right? So even though a particular value might repeat sooner, so for example, 60 is getting repeated at 300. That way, 90 is the same as 270. But that's not what determines the period. The period must be such that it works for every single angle, right? So, which means that nature of the graph should be exactly same. So what happens here happens here. So this is the period, which is 360 degrees. So both are 2 pi radians. Both sine and cos have a period of 2 pi or 360 degrees, whereas tan has a period of 180, which is why in the first quadrant it's positive, back to in the third quadrant it's positive again, covering all, and then first quadrant back it's positive again, right? So tan, if I look at the tan function with the x-axis and y-axis, okay, and I will draw multiple lines at 90, okay, 90, 180, 270, okay, 360, let's say. It's not uniform. Okay, so now if I draw tan 0 is 0. Okay, tan 40, this is 90, this is 180, 270, and 360. Okay, so tan 0 is 0, tan 45 is already 1, and tan 89.99 is a million, whatever, right? So it rises up very sharply like this, right? And tan 90.001 will be negative zillion, right? It'll start from this. In the second quadrant, this is quadrant 1, this is quadrant 2, where tan is negative, right? So tan 180 will be 0 again. So it'll pass, sorry, I'm not able to draw this well, right? Like this. So tan 135 will be negative 1, just like tan 45 is 1. Tan 135 will be negative 1. And then it'll go like this again back to a tan 269 degrees, it'll go up to million. And then again back to this, right? Sorry. Okay. And then it'll repeat, right? Now, here also, this. And if I have to draw an asymptote here, it'll be at -90. So at -90, it approaches a negative zillion, right? At -89 degree, for example, 0 degrees. Okay, so same thing for tan inverse, the domain can be, so if I have to put a block here, this is tan inverse of x, right? The x value can be anything between -infinity to infinity. Tan will support any value. For example, I can ask what is tan inverse of 1000, right? I can ask what is tan inverse of -1 million, right? So that will have an answer, proper answer. So tan inverse, the domain for it is -infinity, less than x, less than infinity. And the range for this, again, we want to cover every value from -infinity to infinity to be supported as an input. So there are two choices. Either we can pick from -90 to +90. Okay, so here we cover everything. Or the other choice is between 0 and 180. And people want to avoid this asymptote in between, right? So which is why you don't pick 0 to 180, because we have this 90 condition in between, right? instead we pick minus 90 to 90. So minus 90 less than y less than 90. You don't want to hit 90 or minus 90 because it's undefined. So the range for tan would be from minus pi by 2 to pi by 2. Okay, makes sense? Okay. All right. And then given any angle, I can express this in terms of, for example, suppose I have tan inverse of 2 by 3. Okay. Suppose I want to write it as cosec inverse of x. Suppose I want to say find x. How do I do this? I'll just draw a simple picture with an angle theta, right? Such that tan theta is 2 by 3. So what does this mean? There is a theta whose tan is 2 by 3. So if that tan theta has to be 2 by 3, this has to be 2 and this has to be 3. Correct? Which means this by Pythagoras theorem is root of 4 plus 9, which is root 13. Right? And therefore, so if that same theta, so this is that theta, right? The theta that we are seeking, which is tan inverse of 2 by 3, which is also cosec inverse of x. So what is cosec theta? I can find out what cosec theta is, right? So cosec theta is reciprocal of sine, 1 upon sine theta is cosec theta. And sine theta is opposite upon hypotenuse. So 2 by root 13. So which is root 13 by 2. So that's my x. So my x is root 13 by 2. Does it make sense? Yeah. So given any tan inverse, I can convert it to some other tan inverse. Okay. And then the last thing I wanted to cover is solving trigonometric functions. So for example, let's say I had one here. Just look. Okay. 2 sec square theta plus tan theta minus 3 equal to 0. Okay, fine. I'll write it down here. 2 sec square theta plus tan theta minus 3 equal to 0. And I'll say 0. In fact, I'll change the question. Minus 180 less than or equal to x less than or equal to 540 degrees. Suppose we have to solve for all possible answers. For now, we'll not worry about the full domain, minus 180 to 540. We'll just solve it normally. So we can use any of the standard relations that we know. The obvious one that connects tan and sec is 1 plus tan square theta is sec square theta, right? Okay, so I'll start with let tan theta be equal to x, right? No, I don't want to keep x here, right? This is theta. This is theta. Okay, so let tan theta be equal to x, fine. Let tan theta be equal to x. So this becomes 2 times 1 plus tan square theta plus tan theta minus 3 equal to 0. This is just a simple quadratic, 2x square plus x plus 2 minus 3 is minus 1 equal to 0. So I can solve for x using minus b plus or minus root of b square minus 4ac, which is 8 upon 2a, which is minus 1 plus or minus 3 upon 4, which is minus 4 upon 4, which is minus 1, and plus 2 upon 4, which is half. Okay, so I'm okay with a tan theta being minus 1 or tan theta being equal to half. Okay, so if tan theta is minus 1, what are the possible values? So tan theta, we know that ASTC, right? So we know that tan theta is, forget the minus sign now. If it's plus 1, we know it's 45 degree, right? Therefore, minus 1 should be the corresponding angle in the second quadrant and the corresponding angle in the fourth quadrant, right? So the corresponding angle to 45 degree in the first quadrant, corresponding angle to 45 degree in the second quadrant is 135 degree. And in the fourth quadrant is 360 minus 45, which is 315. So we'll keep going. And so in the, again, I can write, if I go in the negative direction, because I want to go all the way till minus 180. So I can include minus 45, which will be in the fourth quadrant. I can include, so negative 1 will be here and here, right? So minus 45. And then if I go to minus 180, further minus 45, that will be outside the domain, right? Then my domain is minus 180 to 540. So the negative direction I have only till minus 45. Positive direction I have 135, and then I have 315, and then after 360 I come back another 135, which is 495, I believe, right? And that's it, right? Because after that, no, there will be one more, right? 540 minus your 45, which is, oh, that is 495, right? Yeah. So essentially, yeah, depending on whatever the range of, whatever the domain of values here that you want to cover, minus 180, 540, you can figure out the angles where tan theta is -1. Likewise, tan theta equal to half, I don't have an offhand angle. I'll have to look up from the calculator. So let's say it comes out to be, on the calculator, you can put tan inverse of half, right? So it'll be an angle approximately around, I don't know, 35 degrees or something, right? Because tan 30, we know is 1 by √3. Tan 30 is 1 by √3, which is 1 by 1.732. And tan 45 is 1, right? And oh, sorry, it'll be even less, right? So no, it'll be less than 30 degrees, sorry, maybe 25 degrees. So tan of what will be 1 by 2, maybe 25 degrees or something. Let's say it's 25 degrees. Then you can do the same exercise. So 25 in the first quadrant corresponds to 180 minus 25 in the second quadrant, whatever that is, 155 degree. And then you can go on from there, marking off angles in the second quadrant and the fourth quadrant, as long as you are in the 180 to 540 operating zone. Does it make sense? Dave, make sense? You can solve this, right? Again, when you do practice problems, you'll see for yourself. And then the last thing I wanted to cover was transformations, right? We did touch on it yesterday. So the period for sine x, sine theta is 2 pi. Period is 2 pi, right? So if I do sine of k times theta, then it's a horizontal stretch by 1 by k, or rather horizontal shrink by k, horizontal shrink by k. Shrink, not shrink, but shrink by k, right? For example, sine of 3 theta is going to be a compressed version of sine of theta. The amplitude will be the same, but the period will be 2 pi by 3. So in other words, the period for this will be 2 pi by k. The period for sine of k theta will be 2 pi by k. In this example, it will be 2 pi by 3. And likewise, reverse. So if I have sine of theta by 2, it will be a slow moving function, as in it will go like this, right? Very slow. If sine theta is like this, sine theta by 2 will have a period of 2 pi divided by half, which will be 4 pi. So it will be a slow moving function. Okay, so if I have to model, so let's say I have some data points, typically they give like a seasonal thing, right? From January to December. So I'll have to model something as a sinusoidal, and you might have it ranging from values from, let's say, 17 till 11, right? So 14 becomes the midway point. So I can start off by saying 14. Let's say the values are spread between this in some periodicity, right? I can say 14 is the base value and the amplitude is 3. So 14 plus 3 to 14 minus 3. And with some sinusoidal, I can have a period here. So let's say the period is 12 months or something, right? I can figure out something equivalent of 12 months. So we'll do, when we do exercise problems, we'll see. But you can just manipulate your k such that the period for this, the 2 pi by k, happens to be the 12 months. Okay, and then you can have an offset. It need not start with 0. For example, the sinusoidal need not be here. It can maybe start off from here, right? So you need some offset. So sine of k theta plus alpha. Again, when we do some exercise problems as homework, when we discuss this, it will become more clear. I just want to touch on it briefly. Okay, I think that's pretty much all we need in trigonometry. A lot of practice is needed, but conceptually, these are the main things. Okay, we'll do exercise problems next class for homework discussion. Any doubts before we wind? All okay?
Sir, I've got some doubts.
Yes, go ahead, please, Moksh.
They're not very, I'm not sure whether it's in the IBDB syllabus.
Okay.
But you mentioned, will we be doing hyperbolic trigonometry?
No. So you're talking about sine h of x and cos h of x, right? That's hyperbolic,
Yeah.
which is not there in the portion. But just because you asked, it's very interesting. Actually, you guys can read up or any of your EA exercise. So this is your cos of x, cos hyperbolic function of x. And similarly, this is your sine hyperbolic function of x. But it's not there in the IB. But you can have problems based on that. They can introduce a problem and say, there is a function like this, and then blah, blah, blah. They can ask you some based on that.
Okay. Can I call you after class? I've got some questions. They're out of sleep.
Sure. I have my next class I have to prepare for, and then I have a class. Maybe just message me and then I'll call you later tonight.
Okay, sir. Thank you,
Okay.
sir.
All right. Thank you guys. Bye.
Thank you, sir.
Yes.